Hey friends, so after 15 years working with SQL projects, I have collected the 30 best practices, tips and tricks in order to optimize SQL performance. So today we're gonna go through all the best practices one by one, and as well I'm gonna be explaining why they are best practices. And now before we deep dive into the 30 best practices, I'm gonna give you the golden rule. The SQL optimizer responds differently for different sizes of tables. So this means if you have small and medium tables like hundreds of thousands, you might not notice any performance differences if you are following the best practices, and that's because the size of the data is small. But if you have like million or hundreds of millions of records in tables, you will immediately notice how things can be faster if you follow the best practices. And here is my golden rule. If you get any best practice from me, or let's say you are reading something in the internet, always you have to test using the execution plan. So for example, if you have like two queries are returning the same result of the data, I'm gonna recommend you here to check the execution plan, and if you notice there is no differences between them in the execution plan, then pick the one that you see it is easier to read and to understand. Because sometimes if you are following the best practices for the performance, your query might be like little bit more complicated. So always write the query to be understandable and only optimize it if you notice it is slow. So the golden rule here is always test. If you find you are optimizing the performance with the new query, then pick that. And if there is no gain in the performance, then focus on making your queries readable. So this is the golden rule, always test using execution plan. So let's deep dive into best practices, and we're gonna start by optimizing the performance of our queries. Alright, let's start with the easy stuff. The first step is select only what you need. What I usually see in many queries is that the developers just go and select all the columns from one table. And I can tell you, I cannot think of one scenario where you need all the columns of one table in one query. So for sure in the result we will get like unnecessary columns. And of course reading unnecessary information's gonna make your query slower. So this is usually a bad practice. Don't use select star, but instead of that, go list all the columns that you need for your query. So make sure that you only select what you need, don't go and select all the columns from one table, and with that you don't risk reading unnecessary informations from the database. So always make sure that you select exactly what you need for your query, don't go with a star. Okay, tip number 2, avoid unnecessary distinct and order by. I have noticed that many developers, as they are writing a lot of queries, they tend up by default adding always distinct and order by for each query. And as we review the code and discuss it with the developer, we see that we really don't need to remove any duplicates in the query because there are no duplicates, and it was only a habit to remove the duplicates using distinct. And the same thing for the order by. In many situations, there is no need to sort the data at all. And those operations, the distinct, removing the duplicate and sorting the data, they are very expensive operations in your execution plan. So they're gonna take a lot of resources and slow down your query. So this is considered as a bad practice if you always go and use distinct, even though it's not needed, or you are using the order by in order to sort the data when it is not necessary. So the best practice here is to avoid them. Don't use distinct or order by, only if it is necessary. Okay, the next one, for exploration purposes, limit the rows. So sometimes, especially if you are working with a new database, you would like to explore the tables, just to have a quick peek in order to see the content of the tables. And if your database has a lot of big tables with millions of rows and so on, you will be consuming a lot of resources if you just select the data like this. So now imagine that the orders has like 100 million. As you run this query, the database has to fetch all the 100 million for you. And usually for exploration, it's enough to see like 10 rows, and that's gonna be enough. That's why it is considered as a bad practice if you are exploring the tables to not have a limit or top. So a good practice would be to say select top 10 and then have the same query. So if you go over here, you will get only 10 rows, and the database will not fetch 100 million, it's gonna fetch only 10 rows. And now if you are exploring a lot of tables, you will not consume a lot of resource from the database. So if you are exploring, always limit the number of rows that you are retrieving. Alright, so now we're going to talk about how to optimize the filtering in SQL. So the tip here is to create a non-clustered index on frequently used columns in where clause. So now of course you have to check your queries and so on, and if you see that you are frequently filtering the data using the order status, then it makes sense to create a non-clustered index for this column in order to improve the performance of your query. So for this situation, I'm going to go and create then a non-clustered index for the table sales order for the order status. So once you create it, then you're improving now the performance of your query. Okay, the next one is avoid applying functions to columns in the where clause. So in many cases, what we usually do is that we go and transform the columns before filtering the data. Like for example, here I'm applying the function lower on the order status because I'm searching for the value delivered and I'm not sure about the values in the table, whether they have like a camel case or uppercase or anything. But in order to make sure that I'm gonna find the value, I'm gonna go and say lower the order status and then give here a lower value, and of course it's gonna work. So if we go and search for it, and as you can see we have here the status delivered, and the value is different than the one I used because here we have like a capital first character. But here we have a problem. We have an index on the order status, and now if you use any functions like for example here the lower, the SQL will not use the index. So that means the whole index is now useless and the SQL is not using it. And that's why we consider it as a bad practice to use functions for the where clause, and instead of that, the good practice is that to not use any function and to write exactly the value that is used inside your data. And with that, the SQL gonna be happy and use the index that you have created. Okay, let's have another example about this rule, and here we are selecting all the customers where the first name starts with the A. So with that, we can go and use the function substring in order to get the first character of the first name, and once you match it with A, then you will get the result, and here we have Anna. And this is again bad if you have an index on the first name, and that's because we are applying a function on the column. So this is considered to be a bad practice, and instead of that we can go and use the help of the like. So we can go and search for this pattern where it starts with the A and then we have a wildcard. We don't care about the rest, so it must start with A. So if you go and execute it, you will get the same results. So try as much as you can to avoid the functions in the where clause in order to hit and get the index working. And in many scenarios, we have a workaround in order to use the function without transformations. So try your best to avoid using functions if your column's having an index. Alright, one more example that you see a lot on queries, that you filter by the year. So we are searching for the orders that happens in 2025, and we usually go and use the year order date. And now if you have an index on the order date, this again will not be working because you are using a function year. So this is considered to be a bad practice. Instead of using the year function, you can go and use between. So we don't apply a function on the order date and we say the order date is between the boundaries of the year. Of course, now our query is not looking really cool and easy like the first one, but still with the second one we are hitting the index. So again, while you are filtering, try to not use functions on the columns because it is really waste if you have an index and you are not using it. And most of the cases you have like a workaround for your function. So those are the 3 examples that I wanted to show you about this tip. Alright, moving on to a similar one. It says avoid leading wildcards as they prevent index usage. So this is a similar one. Let's say for example I'm searching for the word gold inside the last name. And here we have to be careful what we are searching for. Should the gold exist somewhere in the last name, or only we are searching for the last name that starts with gold? If it's like that, we are searching only the last name that starts with gold, then we are doing it here wrong. And in SQL, if you are using the leading wildcard, then the SQL will not be using the index. But if you are using the wildcard at the end and the trailing, this one is fine and SQL will not avoid using the index. So this is considered as a bad practice because you will not be hitting the index. Better than that, to not use the wildcard as a leading. And if that's enough for your search, then with that you are hitting and using the index. Okay, moving on to the next one. It says use in instead of multiple or. Or operator is very evil for performance and try to avoid using it. It really kills your performance whether it is in the filters or joins and so on. So now we want to show the orders where the customers is equal to 1 or 2 or 3. And of course, this is considered to be a bad practice and hard to read and so on. Please don't do that. Instead, we have the in operator, and we are saying if the customer is one of those values, then show the orders. So if you go and run it, you will get the exact results. And it not only looks nicer than the first query, but it has as well a better performance. So if you find out writing a lot of ORs, think about the in operator. So those are the best practices for filtering data to improve the performance. Okay, so now we're going to focus on how to optimize joining tables in SQL. So the first tip here is to understand the speed of joins and to use inner join when it's possible. Well, as we learned before, we have like different types of joins. We have the inner, left, right, and outer join. And if you talk about the performance, the best performance you will get from the inner join. And that's because SQL gonna work only on the matching rows. That means the effort and the processing time is better than the other joins. Now in the next one ranking, we have the left and right joins. They are slightly slower than the inner join, because usually they process more data and more rows than the inner join, because SQL will work not only with the matching rows as well with the unmatching rows. So for right and left, SQL has to do more stuff than the inner join. And now the worst type of joins, we have the outer join. And that's because this type works with the biggest number of rows compared to the other types. It's gonna present unmatching rows from the left and from the right tables. So that means SQL has a lot to do, and that's why this join has the worst performance. So here my advice is always try to use the inner join if it's enough to work with the matching rows, and if the matching rows is not enough, then go with the left join maybe. But try your best always to bring the inner join instead of left join, but don't forget inner join filters the data. Okay, the next one, it says use explicit join, the ANSI join, instead of implicit join. Well, it is very old methods on how to combine tables by using the implicit join or the non-ANSI join, where you don't use the keyword join, you just list the tables and then in the where clause you go and join them. Well, it is considered as a bad practice if you join tables like this, the implicit join or the non-ANSI join. It's better to use the normal modern join where you use the inner join, for example. About the performance, there is like no differences between them. And for this scenario, it's very simple. But if you have like a complex query, then joining table like this might be very confusing and really hard to read and as well complex to optimize. That's why the best practice says go with the normal inner join. So go with the ANSI join instead of the non-ANSI join. Okay, to the next tip, make sure to index the columns used in the on clause. So we have to go and make sure that both of those columns has an index, because indexes speed up the lookup process. Without an index, the SQL might go and do a full table scan. Without an index on those columns, the database might go and scan the entire tables in order to find a match, and that is really slow if you have big tables. So now if you go to the customers over here and then to the indexes, we can see that we have an index, a clustered index for the customer ID. But if you check the customer ID in the orders, we don't have an index for that. So this one doesn't have an index. So in order to fix that, we're going to go and create a non-clustered index on the table orders for the customer's ID, since it is a foreign key. So once we do that, we have now an index for both of those columns, and with that, our join gonna be faster. Okay, so now we come to a tip where we say really it depends on. There is like not one clear way on how to do it, but let's say if you have a big tables, it is better to filter data before joining. And here we have like 3 different scenarios that's gonna deliver the same results. But of course the question is which one is the best for performance. So now let's have a look to them. What we are doing here, we are just joining 2 tables, and then we are filtering the result based on the order status that comes from the orders. So in the first query, what we are doing, we are first joining tables, and at the end we are using where clause in order to filter the data. So by looking to this, we are just filtering the data after joining the tables. But there is another way on how to do it. You can go and join the tables, but on the join condition, you can go and add this order status equals to delivered. So we are matching the data by the customer ID, and at the same time we are filtering the data by the order status since we are using the inner join. So the filtering is happening during the join. Or you can do it like this, where we have here more stuff to be added, where we don't join the table directly with the orders. We first prepare the table orders before joining it with the customers. And here our preparation is we are just selecting the columns that we need, and we are already filtering the data before doing the join using the subquery. But if you run all those queries, you will get the exact same results. And of course, there is another way on how to do it. You can go and prepare the data, not in subquery. You can go and use a CTE and then join the result of the CTE with the table customers. So now about the performance, if your query is like small, not that complex, and as well you don't have a big data inside your tables, all those 3 queries gonna deliver the same performance. I know it might sound weird because here we are like filtering after joining, or here we are filtering during the join. Normally in databases, the SQL optimizers are now very smart, can understand that there is a filter here and decide on the best execution plan for you. So actually wherever you put your filter, after, during or before, the SQL is smart enough to do it correctly. So if you don't have complex query and you don't have like big tables, go with the one that suits you. And I really recommend you to go with the first one because it's logical and easier to understand. But if you have big tables and complex queries, the best practices says try always to prepare the data before joining it. So try to isolate and abstract the pre-step in a subquery or in a CTE before joining it with any other tables. And in many scenarios in my project where I have a big table, this did help, where the execution plan was better if I isolate and prepare the data before joining it. So if you have small or medium tables, go with the normal way, use the where clause. But if you have complex big tables, prepare the data in subquery or a CTE and then join it with the tables. Okay, now moving on to tip number 12. It is similar to the previous one, but this time it says aggregate data before joining tables. And again, it is a special case to improve the performance of big tables. So now we have the following scenario where we are joining the orders and the customers, and we are aggregating the data by the customer ID, but we are just joining the table customers because we need the first name. So as a result, we have the customer ID, the first name, and the order count. So the standard way is to join the tables and then do a group by in order to summarize the data. Now, if you look to this query, we actually don't need the join in order to do the aggregations. We can do first the aggregation, like preparing the orders with the aggregated data, and then join the result with the customers in order to get the first name. So again, we prepare first and then we do the join. And we can do that using either the subqueries or using the CTE. So in this scenario, first we are doing the group by, we are aggregating the data, and the result of this is joined with the customers tables in order to get the first name. Now, of course, there are like many ways on how to do it, like for example, as well using the correlated queries, where we can go and use the subquery in the select statements and then use the where condition over here to make the correlated query. Now, all those 3 gonna deliver the same results, but the question here again, which one has the best performance? Well, I can go immediately and tell you that correlated subqueries are the worst one. Always avoid using correlated subqueries, they have really bad performance. And that's because SQL gonna go and do the aggregations for each customer individually. So it's gonna go like for each row and doing aggregation, then to the next row and so on. So it takes a long time. So this is bad practices, don't use it. Now we are left again with the first option and the second option, and here my tip gonna be like the previous one. I'm gonna say if you have small to medium size of tables, then go with this one because it is easier to read and to understand, and you will gain exactly the same performance as this subquery. But if your tables are big, the best practices is to prepare first the data, to group up the data, to filter the data, and to isolate it in a subquery or a CTE before joining it with the final table in the final query. But again here, only for big tables, and always test, check the execution plan, whether you are really getting any benefits from it. Alright, so if you have big tables, try to prepare the data first in CTE subquery and then join. Okay, moving on to the next tip, it says use union instead of OR operator in joins. So what this means, sometimes let's say that you are joining 2 tables, the customers and the orders. And now about the join key, you can see over here, it says the customer ID should be equal to the customer ID from the orders, or the customer ID should be equal to the salesperson's ID. If one of these 2 conditions is fulfilled, then we have a match. And I can tell you the OR operator over here is a performance killer. It has really bad performance, so try to avoid it. Don't use OR in the joins. It has a lot of problems, like it avoids indexes, it creates like loop joins, and so on. That's why we consider it as a bad practice. And now in order to get the same results, we can go and split the joins. So we can go and have two queries. The first query is joining the data based on the customer ID, and the second query based on the salesperson. And then we go and merge those two results using the union. It sounds like bigger and too much for the SQL, but with this you will get better performance than using this simple OR operator. So again, if you have big tables, try to avoid using OR, and instead of that, go and use union. Okay, the next tip says, check for nested loops and use SQL hints. Now imagine that we have like big tables and we are joining tables. So now if you are checking the execution plan, you have to check always the join type. So for example, here it is using the nested loops, which is of course is okay because we have small tables. But if you have big tables and still SQL is using for some reason the nested loops, then this is alerting. So in order to change this, what we can do, we can go and use the SQL hints in order to force SQL to use the hash join. Hash join is really good if you have a big table, like for example the orders, that is joined with a small table like the customers. So now what we can do at the end, we can write over here option hash join. So let's go and execute it, and let's check the execution plan, and with that we have forced SQL to use the hash join or hash match. Again, you have here really to evaluate your tables. If you have like small tables, don't bother with that. But if you have big tables and SQL still doing the nested loops are usually very slow because you have a lot of iterations and so on. And with the hash join, that small table is going to be stored in the memory, and then you have really a quick matching between the two tables. So those are all the best practices and tips on how to optimize joining tables in SQL. Alright, so now we're going to talk about union, and here is the best practices. It says use union all instead of using union if duplicates are acceptable. So it's very simple. If the duplicates are acceptable, or let's say that there is no duplicates, then don't go with the union because it needs more time to be executed. SQL has to go and check row by row whether we have duplicates or not, and this usually takes longer time than using the union all. So if duplicates are acceptable or you don't have any duplicates in your data, go with the union all. SQL just have to go and merge all the data without checking anything, and the performance is gonna be faster. Alright, the next one is a little bit tricky. So it says use union all together with the distinct instead of using union if the duplicates are not acceptable. So you want to remove the duplicates. So we have learned that in order to do that, we're going to go and use the union. It's going to go and merge the data and as well remove the duplicates, which is really okay to use it if you have like smaller data or medium. But let's say that you have like millions of rows, which is really okay if you have like medium and small tables. But again here, if you have huge tables, big tables, hundreds of millions, the best practice says go with the union all and afterwards use a distinct. So in the subquery, we are using union all, but in order to remove the duplicates, we use the distincts. But again, here you have to test it to check the execution plan. If you are getting benefit, then go with this version. But if your data is not really big, you have hundreds of thousands, so go just with the normal union. The code is smaller and you will get the same effects. But only for large tables, you can go with this best practice. So that's all what I have for you for the union. Okay, so now let's talk about aggregations, and here the tip says use column star index for aggregations on large tables, like for example fact tables. And that's because column star index gonna compress the data, so the size of the data gonna be smaller, and as well the aggregation is super fast because we are selecting only the relevant informations, only the relevant columns. So it makes it a perfect setup for aggregating large tables. And now let's say that we have hundreds of millions of orders and we have this query over here. So the best practice says convert this table to a clustered column star index. So if you go and create this clustered index over here, the whole table gonna have amazing performance for aggregations like this. Alright, so to the next one. It says pre-aggregate data and store it in a new table for reporting. So let's say that we have like a big query where we are aggregating the data and so on. And this query takes really long time, let's say like 5 minutes or something like that. But now the problem with that, I would like to show the results as a report, maybe to my manager, or let's say during a meeting. It's gonna be really bad if everyone have to wait until the query is done. So the best practice here, if you have like a query that runs very slow, what you can do, you can go and store the results in a table. So if I go over here quickly and say into sales summary, what can happen, SQL gonna store the result inside this table. So let's go and execute it. And now with that, we have a nice table where everything is prepared. So all what you have to do is to go and query this table. And of course, it's gonna be very fast because it's only select statements. And with that, you have like prepared and pre-aggregated the data to have like fast reports. So don't forget about this. If you have a big query, you can insert the result of this query in a new table in order later to use it for reporting. But one thing that you have to make sure that you have always to update this table. So if we have new orders, it will not be presented inside the sales summary. You have to go and run this query again in order to get new data inside the sales summary. So those are the tips on how to improve the performance of your aggregations in SQL. So now what is happening here? I would like to show the orders, but only from customers from USA. So if you check this query over here, we are joining the tables order and customers, but mainly we are showing only the orders information, and that means we are using the customers only to filter the table orders. And there are like multiple ways on how to do this task. So it's not only the joins, you can go and use the exists as a subquery, and as well you can go and use the in operator in the subquery. And now comes the old but gold question. Which one is better? Should we join or use exist or in? And oh my god, if you go to the forums, you will see people fighting about which one is the best.
Clean technique,
come on, do that again. Do that again, I dare you.
Okay, break. Break.
Oh, you can't see? You can't see? 1 point, 2 points.
Now about the best practices, everyone agrees that don't go and use the in operator. So this is the bad practice. So bad practice, avoid it, don't use it. And of course, I'm always speaking about big tables, okay, not small tables. So we don't go and use this in order to filter one table based on the result of another table. So don't use in operator in this scenario. Now here comes the conflicts. We have join and exist. Well, about the performance of those two, they are very similar for medium tables. Like I'm speaking about 100 or 1000 and so on. But still you have to test it. You have to go and compare the execution plans, and if you are getting like identical results and both of them are having the same speed, then I prefer to go with the join. And that's because, to be honest, it is easier to write than writing the exists. So I'm gonna say from my point of view, this is best practice if the performance equal to exists. But now what happens for me is that sometimes I get better performance using exists. So I'm gonna say from my point of view, the best practice here. And now you might ask why we are getting with the exist better performance than in the inner join. And that's because SQL has only to check the existence of data from the subquery. But in the other hand, with the inner join, SQL has to go and start doing matching between two tables. So it's gonna go and evaluate all matching records and so on. It is not evaluating whether it exists or not. And as well, sometimes SQL has to deal with more rows because you might introduce duplicates as you are joining tables. And this will not happen using exists. So for some scenarios, if you are using exist, you might get better performance than using join. But everyone agrees to not use the in operator. Okay, the next tip is to avoid redundant logic in your query. This happens a lot if you have a lot of subqueries, and if you analyze it, you might find sometimes there is like redundancy. So for example, this query, I would like to have like a tag for each employee, whether the salary is above the average or below the average. So now we might do it like this. We say, okay, let's get the data for employees where the salary is higher than the average, and you go and calculate the average in a subquery. So if it's higher, then you write here above average. And now we say, okay, let's go for the below average. So we do a union all, and the condition gonna be salary is less than the average. And now by checking this, you see that there is a problem. First of all, we are querying the employees like 4 times. We have 1, 2, 3, 4. So we are scanning the table employees 4 times. And as well, we have the same logic over here. So we are calculating the average of salary twice. So this is, of course, I can say a bad practice, and there is like many ways on how to do it better than that. For example, you can go and put this subquery in ACTE and then use it multiple times, but there is like better solution using the window function. So if you check this, it is very simple. Let me execute it. We are reading the table employees only once, and then we are using the case statements. If the salary is higher than the window function, so we are calculating the average on top of the whole table employees. If it's higher, then write above average. If it's lower, then below average. So as you can see, it is easier to read and it is smaller, and the performance here is way better than reading 4 times the employees and repeating the same logic. So here you have always to look to your queries, and if you see that you are repeating the same things over and over, then you are writing a bad query. Think about alternatives like CTE, window functions, and I'm sure you will find a better way than reading the table several times or repeating the same logic several times. So as you can see, optimizing the queries is not always about using indexes and partitions, it's all about using best practices. Alright guys, so with that we have covered a lot of best practices on how to optimize the performance of your query. And as you can see, it's not always creating indexes, right? In many scenarios, it's about how you write the query. And now in the next section, I'm going to show you the best practices on how to create tables. So the best practices of DDL, Data Definition Language. If you have a poor definition of your tables, this has a great impact on the performance of your queries. Alright, so now we have here like a DDL in order to create a table, customer info, and it is not really following best practices. So let's go through it one by one. The first tip is try to avoid the data types varchar and text if it's possible. The varchar and text, they are like one of the worst data types for performance, because they consume a lot of resources whatever you do. Like for example, if you are sorting the data by a column that is varchar or text, it is very expensive operation. The same thing if you go like and create an index on top of such a column, it's going to be as well expensive. And they cause a lot of problems with the data fragmentations and many issues. So try as much as you can to skip those data type if it's possible. So now let's go and review all those columns in order to see whether we can change something about it, because it has a lot of varchars. So the first one over here, we have the varchar because it is the first name. Well, it is okay. Now moving on to the next one, we have the last name as a text, which is not really good because text is worse than varchar. So it's better to use varchar than a text. So here we have to fix it. So varchar, and I'm going to go with the links 50. Now moving on to the countries. So the country is going to be varchar. We cannot change that. It contains characters. So the next one is the score of the customer. Here we can do something about it because scores are only numbers. So that's why we can go and skip this one. So let's remove it and say you are integer. And with that, we have avoided using the varchar. And the same thing goes for the birthday. The birthday is a date, and here we have it as a varchar. Well, this is not really good, and we can skip that by having this column as a date. So date is way better than having a varchar. Alright, and the next one is integer. So with that, we have fixed few stuff. So we have fixed the score and the birthday, and with that, we have saved some storage. If we have an index on the score, it's going to be way better than having a varchar. And if you are filtering the data based on the birthday, it's going to be faster. So again, try your best to avoid the varchar and the text. I have seen in many projects that a lot of developers tend to use the varchar. And I understand it is easier to make everything as a varchar than deciding whether it is an integer, date, float, and so on, because you can fit everything in the varchar and text. But this is lazy. Take time to understand the content of this column and try to assign it to the correct data type, because this has really impact on the performance. Okay, to the next one, it says avoid using max or overly large lengths. So now we have to keep our eyes on the lengths of each data type, especially the varchars. Not only it's gonna waste like a lot of storage, it also gonna like mislead the SQL by creating large indexes, which is totally unnecessary because the data itself is small, but because you have defined like a large length, SQL gonna check those informations and make decision to make a big index. And large indexes are always problematic because they're gonna slow everything down by sorting the data, by retrieving data, by updating the index. So it is really bad practices if you go blindly and define everywhere max or 255. Again, give it a chance to think about each column and predict a length for it. So for example, if we check over here, we are saying first name varchart max. Well, most of the first names are short, so we don't need like the maximum size of a varchar to fit a first name. So here we can go easily instead of max with the 50. And the same thing goes for the column country. We don't need 255 characters for the country name. We can go with something more realistic, like around 50. I think you can even go smaller, but it's fine to have 50. So the best practice here is to analyze your data and to predict the size of each column. And don't be lazy by just defining max everywhere. I know it's faster, but it's bad for performance. Okay, what do you have else? Use the constraint not null as much as possible. The not null is amazing and has a lot of advantages. Of course, the biggest advantage is that's the data integrity of your table. So with that, you make sure no nulls are inserted in specific column. But it is as well good practices to use it for improving the performance. Because if you are creating an index, you're gonna get a better index performance since SQL knows there is no nulls inside my tree, inside the index. And in the other side, if you are writing a query, we tend to use a filter where we say a specific column should not be null. But if you make sure that in the DDL it is not null, then you can skip this filter. And with that, you are reducing the size of your query. So what we're going to do, we're going to go through all the columns and decide whether it is not null and null. So for example, the first name and the last name, they should not be null. So that's why I'm going to say not null. And the same thing for the last name, not null. For the customer ID, we're going to talk about it soon because we're going to convert it to primary key. And primary keys are usually not null. So now for the country, we may have it in the business that's it should not be null, so we go and make a constraint about it. Now about the total purchases and scores, if it is new customer, maybe we can have a null inside our data, so we're going to leave it empty. And I think birthday is going to be usually optional, so we're going to leave it as well. And whether the customer is employee or not, this could be as well a null. So with that, we have found out like 3 columns where we can have a constraint about the not null. And if we go and create like an index on the country, it's going to be a better index. Okay, moving on to the next one, it says, make sure that all your tables inside the database have a clustered primary key. And as well, it's going to help you building the relationship between tables where you have primary keys and foreign keys, and you can join tables then very easily. And as well, a primary key has importance for the performance. And in SQL Server, the default is going to be a clustered index, which is really good to have an index on the primary key because sometimes you are doing like an update operations or delete operations. It's going to help out by the lookups of joining tables. So there are a lot of performance benefits of having a primary key, and make sure that all your tables having a primary key. So as you can see, the issue of our table, we don't have a primary key, and our primary key going to be the customer ID. So let's go and do that. Primary key, and as I said, as a default, it's going to be clustered, but I'm going to write it down. In case if you are working with different databases, make sure it is clustered. Okay, moving on to the next one. It's not only about the primary key, we have to take care of our foreign keys. So the best practice says, create non-clustered index for the foreign keys if they are frequently used. The foreign keys are usually important in order to connect and join 2 tables, and usually we frequently use it. And not only that, we use it sometimes in order to filter the data. And if you create a non-clustered index for that, it can improve the speed. So what we're going to do, it's very simple. We're going to go and create a non-clustered index on our table customers info for the foreign key employee ID. So how to do it is very simple. We're going to go and say create non-clustered index on our table the customers info on our foreign key the employee ID. But again, make sure that this is an important foreign key that is used frequently from your queries. Alright friends, so as you can see, there are a lot of best practices on how to improve and optimize the DDL. Having a healthy DDL can improve the performance of your queries. Now in the next section, I'm going to show you the best practices and tips and tricks about indexing. So let's go. Alright, the first best practices and the most important one is avoid over-indexing, because too many indexes gonna slow down the insert, update, delete operations, and it's gonna confuse as well the execution plan about choosing the right index, and the performance of the whole system gonna go down. And another tip is to monitor the usage of the indexes. And I can tell you 90% of the indexes that is being created usually are not used at all. So they are taking a lot of space, slowing down everything. So go and drop those unused indexes in your system. The next best practice is to have a regular job, like maybe a weekly job. So first you have to update the statistics regularly. As you are inserting new data and modifying data inside your database, the statistics and the metadata of your tables might get outdated. And this is really bad because you will not get an optimal execution plan for your queries, and this is gonna slow down your queries, of course. So regularly make sure that all the statistics are updated in order to have an optimal execution plan. And what else we can do in this weekly job is that we can go and rebuild and reorganize our indexes. And that is to make sure that we are preventing data fragmentations in our indexes. Data fragmentations in your indexes is really bad because there will be a lot of unused spaces. The order of your clustered index will not be correct. So make sure that at least weekly you are rebuilding and reorganizing all your indexes. So those are the best practices of improving the performance and optimizing your indexing. If you are struggling with very large tables in your projects, like having fact tables, then go and use SQL partitioning in order to divide these tables into smaller pieces, which can improve the performance, whether you are reading data from the table or writing data. And of course, you can go and mix things where you can go and apply a column store index on this partition table. Then you will get the best performance if you are having large tables. Alright friends, so that's all. Those are the best practices, tips and tricks that I've collected in the many years working with SQL. And now my final thoughts about this is that try always to focus on making clear queries, make it like easy to read and easy to understand, and try to optimize the performance only if it's needed. So if you have like small database, don't worry a lot about the performance because the SQL optimizer gonna pick the best plan for you, and focus only on having simple queries. And if there is like performance problem, always test using the execution plan. It should be your judge. So if you are applying an index or you are rewriting your queries, always compare before and after using the execution plan. And if you are gaining more performance, then adopt the new query or the new index. Alright guys, so that's all about optimizing the performance in SQL. In the next tutorial, we're gonna focus on the stored procedures. It's gonna be amazing, so stay tuned. If you like this video and you want me to create more content like this, I'm gonna really appreciate it if you support the channel by subscribing, liking, sharing, commenting. All those stuff gonna help the channel with the YouTube algorithm, and as well my content gonna reach the others. So thank you so much for watching, and I will see you in the next tutorial. Bye.